Okay, so good afternoon, everyone. Thank you for joining NIF Connect. Right. So as you can see from the slide, right, my name is Mervin, and I am the one who moderates NIF Connect. Right, and I'm also here to explain what NIF Connect is all about. Right, before we get started. So NIF Connect initially. Shom had this idea about NIF Connect and what it's supposed to be. By the way, Shomron is the founder and CEO of NIF. And the whole idea was it's to be a collaboration, between teams, between everyone who's using NIF Connect, right, and NIF and the product in itself, right, and this extended, further into the whole aspect of it, including all cybersecurity and enthusiasts as well. So this community, over here, this community has grown a lot, right? We are into the seventh Connect, right, successfully, fingers crossed. Yes, everything working well. So the Connect is now a platform wherein, a lot of people are coming, learning, asking questions, learning about new technologies. We get to see a lot of things and how technologies work together. The whole idea of a community is the same thing as is the fact of technologies working together. So people come together, work, understand, ask questions and learn same in the same way that technology comes together and works together to provide an end goal and an end result, right, and that everyone can benefit from. So that is what NIF Connect is all about, right. The focus, or our focus, is mainly not on the offensive side. That's something that has been done over and over again. We want to shine a spotlight. I've said this many times. You want to shine a spotlight on the unsung heroes, people, some of these people who spend hours and hours, staring into the monitor, make, their whole effort is to make their organization secure, right. And that is what, we want to, sing praises to those unsung heroes, remember them, and just keep an eye out for those people. Like, they are the ones who keep us secure, keep networks and organizations secure. So this is what NIF Connect is all about, right? So that being said, I will move on now. Just wanted to remind everyone that this meeting is being streamed live on YouTube, right? So if at any point in time you get disconnected or you're not able to reconnect back to the NIF Connect, all you need to do is log on to YouTube, and you can view it over here. The NIF channel is mentioned very clearly. So yeah, please go ahead, and a recording of this entire session will be sent to everyone with onto their registered email addresses, right? So yeah. And another aspect of, as I mentioned, NIF Connect is all about sharing all the knowledge that you have, and we give this opportunity to, connect members of the community, right? So all you need to do is share your knowledge and become a Connect community hero, right? And presenters are, assured Amazon gift voucher worth rupees 1,000. You can join the ranks of our existing community heroes, as you can see many of them, right? And also to say that we'll have more of them coming as well. And also looking at some of the technologies partners and knowledge partners who've made these sessions, possible, like by contributing in terms of their knowledge, in terms of the technology that they have provided. So a lot of them, we're always thankful to them, and we'll keep increasing the, many of the community members have learned a lot from them, right? So is a big thanks to our technology and knowledge partners. So without further ado, I'll break down the agenda for today's session. Today's session is a really good one, right? We have first time speaker, so Varad, who is going to be talking about, detecting lateral movement and data exfiltration with Smokescreen and NIF. We also have Smokescreen expert, who will basically be telling us about, adversarial approach to targeted threat detection, and this is going to be a very interesting one. And we end the session with Mukesh, who will be doing part 2 of NIF command and control, which we affectionately call DCC, right? So part 1 was covered in the last Connect by her, and part 2 will be conducted by her in this session. So without further ado, I will, introduce the first presenter that we have, who is Varad Joshi. Now, Varad is the product manager at NIF. Now, he comes with a experience on multiple SIM solutions, and what he likes doing is being in front of the customer to talk about how they can use various platforms for their benefit. Now, he has a knack of conceptualizing use case based on business needs. Now, during his leisure time, Varad likes traveling, making friends, and he loves experimenting with food. Right now, this is what he gave me to read about him, right? The last thing now, and he's giggling at that as well. But yeah, he's a really fun guy to have around. Always, if the situation is tense, yeah, you can expect Varad to crack a joke here and there, and uplift the moment a bit, and you feel a bit lighthearted after that. Yeah, so great stand-up guy, Varad. And yeah, I will pass it on to him in a short while. Yeah, big thanks to our session contributors, Smokescreen. Basically, a little bit about Smokescreen. So Smokescreen brings military reception tactics to the digital battlefield. Their solutions protect some of the most highly organizations globally. These include leading financial institutions, critical infrastructure, and Fortune 500 companies, right? So the session has been contributed by Smokescreen, who also are our technology partners for this Connect. And so over to Varad, who will take the session ahead.
Thank you so much. Thank you so much, Marvin. Uh, Introduction was well. Yeah. I mean, thank you so much for the great introduction. Well, without further delays, let me go ahead and share my screen. Okay, hope everybody can see my screen here. Great. I got a thumbs up from Marvin, so we are good to go. So this is a very basic console, a Google type interface that NIF provides, where you can write a lot of queries and so on. What I'm going to do is I'm going to go to repository. Repository is basically the packages that we have. uh, I'm going to show you something on Smokescreen, so I'm going to go and look at the repo of Smokescreen, and then we'll see what all do we have there. Right, so I've got, of course, the first thing that I have is parsers. Then I've got a lot of modules that we can raise, and at the end what I have here is the workbook, with the name decoy detection. Let me go ahead and edit this and see what do we have inside this workbook. So workbooks are basically the queries that you have written, and then you can put the cron here, so that based on the you based on the schedule that you want, you can put the cron here, and the workbook will continue to run in the background and will continue to work based on whatever you've mentioned here. Now let me copy this and put this in the search bar here. So what am I doing here? I'm fetching star, which is basically I'm fetching all the events where log name is equal to smokescreen hyphen ceph. So basically I'm getting smokescreen logs where severity is high, and duration I've mentioned is 1 hour. Decoy type, which is basically the field which is generated in smokescreen log, is equal to cred theft. Basically somebody is stealing credentials. And the chain phase, really interesting stuff here. So the chain phase is basically telling you that in MITRE kill chain, what is the phase of the attack. So right now we are at the privilege escalation. Just to show you that, so we are at this phase right now. I'll go back to the query, and then I'm doing a group of count unique, and then couple of fields that I'm passing on here. Let me run this query real quick. There you go. So there is this domain where where on on which the stealing happened, right? So that domain is my domain, which is nif.it. The user whose credentials were stolen is helpdesk at nif.it. This is the source IP. I'll not go in detail here, but then, if you can see, we've got some context menu here, right from this IP address. You want to do a lookup to virus total, or you want to get report from virus total, or you want to do a domain tool. So some of the things that you can do right from this window are listed here. um, so yeah, I'm looking at last 1 hour of data from Smokescreen. If I remove this real quick so that you know how we retain raw data as well, there you go. So this is the raw data, and these are the fields which are extracted from the raw data. Okay, I'll go back and I will add where I did the group count. So now I have the domain, and now I have the targeted user. What I will also do is I will raise a module. So, based on uh, the cron schedule, so you can keep it 5 minutes, you can keep it 1 hour, and so on. If there is an entry here, well, what I want to do is I want to raise a module. So raise a module. This is the command there, and this is the repo name, and then this is the module name, which I showed you about 5 or 6 modules which were there. And then this is the source IP, the IP address. I'm passing that as a token. uh, Raise it with severity 5 and keep this module in the inbox. I'm going to show you in the inbox as well for about 12 hours. And then if this is happening with a cron, this query, the complete query will run automatically, and then we should see a module being raised. Let me go and see if I can see the module here. There you go. A few seconds ago, there was a module which was raised, credential theft attempt detected. So this is basically I'm looking at logs from Smokescreen and then raising a module in NIF. This was about somebody stealing my credentials and trying to do something. Then the next one is somebody coming inside with telnet, and if there is a lateral movement which is detected, and then just to see the logs, I am going to see this in the window again. So yeah, sorry, not telnet. Well, this guy is using FTP. So I'm looking at all the events where event type is equal to FTP. Again, 1 hour of window. Decoy type is network, because this is the movement I'm seeing on network. Chain phase, which is basically again miter. Which phase in the miter kill chain. It is lateral movement. Just for the reference, there you go. We detected this at this phase. And when I hit enter, well, this is the source IP which is trying to do an FTP. This is the user, Mukesh. Command is input, which is basically, it's an FTP command where somebody is trying to steal multiple files using FTP. And these are the events that I'm seeing with the similar events. Now, again, I'm raising a module with this. I'm raising a module for this scenario as well. I'm quickly going to the next pipe, and boom. So while I'm raising the modules here manually, I'm not. I'll repeat that. If you have a cron scheduled, if there is a scenario which is meeting the criteria of the query that you mentioned, the modules will be raised automatically. So there you go. So we saw a couple of scenarios so far. The first one was somebody tried stealing credentials. The second one was somebody trying to steal uh, some important information with the help of FTP. And the third one is basically file theft or the data theft uh, events which we have received in Smokescreen. So yeah, there you go. So here the decoy type is file theft. Again, I'm looking at Smokescreen data for last 1 hour, and if I hit enter, it's going to give me some more information. Okay, I'm gonna stick to 1 hour of window here. Okay, so now in this scenario, I am also looking at which file was that, which they were trying to steal. So in this case, it's asset inventory dot doc, and the mode. So somebody tried opening explorer dot exe, and then this is the source IP. Uh, which is an external IP and so on. So there you go. I am going to raise a module for this scenario as well. Boom. So we received it. We looked at about three scenarios, and we raised modules for all three scenarios. Somebody stole the credentials, somebody tried transferring a lot of files using FTP, and then I am looking at which file was that, and how did the mode from where they tried FTPing, or no mode from where they tried stealing the data. Now, this is really, really basic if you ask me, right? Now, I'm looking at logs from Smokescreen. I'm giving you some visibility out of it and so on. Now, here comes the real magic of NIF, right? So how about you as a security analyst or as a customer, you want to see the correlation, right? So you want to see A, B, C, these three things happened. Well, what is the total outcome? How do I look at it? So now in this case, let me quickly copy the query here, and then I can show you. I'll remove this. So here I'm looking at, in case if, see if there is this module detected within last 1 hour. And if there was, then, put that as hash A. Second, I'm also looking at that, in case if there was FTP access detected, again, last 1 hour, save that as hash P. And similarly, if there was a file theft attempt detected, save that as hash 3. Then what I'm doing is I am raising an incident. So as of now, I should have three modules with me. Okay. Oops, sorry, give me 1 second. Yep. Or rather here. So yeah, there you go. I've got three modules here, which I've just raised. One is again, credential theft, FTP access, and which file was that? So I'm gonna uh, those three modules I've put in three labels: hash A, hash B, and hash C. Now, if there is a common source IP which is contributing for all three modules, in that case, I see that these three modules are kind of correlated. So there is a relation among these three modules. Now, in that case, I want to raise an incident so that my security guys, my security analyst can start working on it. So now if I hit enter, what it's going to do is it will see if there is a common source IP, and then if the answer is yes, there you go. I should be able to see an incident being raised here. Let me, yeah, there you go. So the while the other modules are just white, or no, I mean it's just a gray circle. These three, the correlated modules, I can even click one of these here. And there you go. There's a new incident which is telling me that these are three different modules which were raised for three different issues. But then NIF sees this as one incident, which is basically correlating all three modules. So this is the real power of a big data security analytics, where I'm fetching data, I'm fetching raw logs from Smokescreen, three different scenarios, but then NIF is able to correlate how those three are linked, and NIF is able to raise an incident that, guys, there's something wrong here. Why don't you go ahead and look at it? So there is so much more to NIF than just a correlation rule, which is combining different modules. There is so much more in Smokescreen as well. So we have a gentleman from Smokescreen who's going to tell us more as well. But then this is pretty much what I wanted to cover about how NIF and Smokescreen are integrated well with each other, how I can take their data, and I can give you visibility in NIF, and can give you correlation as well. Well, thank you so much for listening to me. I hope you found this useful. Marvin, over to you, man.
Thank you. Thank you. That was Varad again with his presentation, which was really nice. And yeah, I'm surprised that he didn't crack a few jokes in the middle, which he usually tends to do. But yeah, I believe, yeah, that was a good session on how Smokescreen and NIF works together. There's a lot of information. There's more stuff that we're trying to build with Smokescreen as well. That will soon to come in the near future, right? So I see that we have a bunch of questions, right? And yeah, this is a good time to inform everyone that we're still handing out Amazon gift vouchers. We basically have a bunch of Amazon gift vouchers to hand out, right? So yeah, go ahead, ask questions, right? And all you need to do is hit the Q&A tab, right? Mention the name of the presenter. Now, if you have any questions for Varad, all you need to do is mention Varad's name, and followed by the question, and I'm sure the presenters will take time out to fill in those, answer them live, or also write in those answers to those questions, right? As you can see, we have a bunch of the previous connects, right? And Social Geek Award, yeah, another way of winning an Amazon gift voucher. All you need to do is tweet on Twitter and post on Facebook using our tags, basically hashtag NIF Connect and @NIF HQ. And there again, you stand a chance of winning an Amazon gift voucher. So go ahead, go crazy, go postal with the posts. Right. So we're coming up to our featured presenter for this afternoon is Kushaagra Mehra, right? Great guy again. He's the deception campaign strategist at Smokescreen, right? And just to give you a little bit about the background about Kushaagra. Kushaagra he specializes in adversary countermeasures across several industry verticals. Now he's a subject matter and expert on deception. He has worked on over 30 at scale enterprise deployments wherein he has designed campaigns to mitigate blended threats and reduce the attack surface for advanced adversaries. He holds a master's degree in computer security and resilience from Newcastle University. And so his topic is an adversarial approach to targeted threat detection. And tech and knowledge partners for this session are Smokescreen. So that being said, we move on to Kushaga, who will take this whole session ahead.
Thanks, Marvin. All
Thank
right,
you,
so
Kush.
I'll
We
be
can hear
getting
you.
started initially with a bit of a presentation, just introducing folks to some of the concepts we're thinking about, introducing folks to how to think adversarially about defense. I'm going to talk about where kind of we can bridge the mindset gap and strengthen our defense with more of a mindset change than necessarily technical change, and how technical controls we bring to the table can augment that. So just excuse me once. Yeah, I think I was having some trouble with my audio. I think we should be good now. All right.
We can hear you great, Kush. Yeah.
All right. Let me just get my screen sharing going then. And yep, there we go. All right. So just before I get into the nitty gritty, a bit of background about Smokescreen. a lot of what I'm going to talk about today is something that comes from a perspective informed by Smokescreen's work on Red Team and Blue Team with multiple organizations, including myself, but also the rest of the team, where we've had folks on the team that have engaged with Fortune 50s even and broken in despite the millions of dollars of technology. You can break in without getting detected. So why is that? That's something I'm going to talk about. A lot of these ideas are not just something that you've picked up from shelf in the from the bookshelf. It's something that we've actually tried and tested. So that's basically what I'm going to be covering today. I'm going to be covering adversarial thinking, which in our opinion is how you can really step up your security game on the defenses. So if you look at the image on the right, most people generally, they see a bunch of rocks. I'm going to give you like maybe a few seconds to see if you spot anything unusual about that image, anything that jumps out at you, anything that looks a little out of place. The eagle-eyed among you might have spotted this sniper on the upper right. That's basically what we seek to do with adversarial thinking. We want to make the environment hostile to an adversary, but to somebody who's just going about their day-to-day, it should not really affect them. We do that with deception, but our whole approach that I'm going to talk about here is not just tied into Smokescreen's technology. It's about how you can use various approaches, tie them together to make defensive security as a whole much stronger. Like Mervin was talking about before, where at the end of the day, we have a common goal where we want to prevent breaches. So let's play a little game before we get started, right? Let's imagine you're an attacker. I'm going to put you in the attacker's shoes. The pot of gold on the upper left that you see, that's your target. That's what you want to go for. Then let's say that's you as the attacker on the bottom left. I've got all my traditional defenses that I'm supposed to have. I've got my firewalls, I've got my IDSs, IPSs, I've got a SOC team. Now that leaves you with a certain number of attack paths, most of which are ruled out because of the defenses I have in place. However, once again, if you give it just a few seconds of thought, you're probably already going to have found a way to the pot of gold, right? Now, to those of you who were thinking about how to achieve this, and even to those of you who actually did manage to spot that path, that's it. Adversarial thinking, you've actually managed to exercise it. So it's actually that simple. What actually underlies this though? Notice that you didn't think about how to defend, you thought more about how to attack, how to get to your goal. And then if you want to defend, you've got to figure out ways to prevent the attacker from achieving their goal successfully. So that's basically the difference. One of the key differences between defenders and attackers is defenders tend to think in lists where, we say that, okay, I've got strong passwords, I've got my 2FA, I've got my firewall, and I've got all the stuff I'm supposed to have. Whereas attackers, they kind of tend to think in graphs. They tend to think more about what are the gaps that are available. You can say that you have all the stuff on the left, but that could still leave, like we saw in the game earlier, like we see on this graph here, that could still leave one attack path that is still available despite all the layers being covered. So that essentially results in these kinds of attacks, right? On the enterprise side, you've got someone like Target, where you've got really good tech deployed. They had FireEye's tech deployed, quite capable tech. It even detected the attacks, right? But one of the things that was missing in the checklist was whether every alert is actually being monitored. And at sometimes that's just not feasible. At the scale of larger enterprises, it's just not feasible. On the other hand, in terms of personal experiences, the story on the right is something I would really recommend reading. It actually makes for a good, quick read over the weekend, where this writer, he had a really valuable Twitter handle. Somebody wanted it, and despite him having all sorts of security controls on his various accounts, the attackers found one set of steps that, despite these controls, there were certain gaps that were left in the steps, and they could exploit those steps to get control of his various accounts, including the one that they actually wanted, which is his Twitter handle. So to talk about why this is successful, it's important to understand something called the OODA loop. Now, the OODA loop was created as a concept by a World War II fighter pilot. It was developed for the domain of aerial combat, but it kind of applies to pretty much any adversarial face-off where two sides have differing goals, whether it's cyberspace, whether it's aerial combat, or whether it's even business negotiations and interpersonal relationships. You want to go out for dinner to someplace, your friends want to go elsewhere. Whoever can complete this loop first gets their way. So OODA essentially stands for observe, orient, decide, and act. And when you're able to complete these, whoever completes this loop first defeats their opponent. Now, think about it from an attacker's perspective. They've got to break into an organization. Once they've broken in, they need to observe the environment. They need to figure out where in the network they are, what are the network assets around them, what are the user they're logged in as, what privileges does that user have, and so on. Basically, this is something that you might have heard called situational awareness. Now, if you have that, that's a good baseline to start with. Then you figure out, I have various goals I can orient myself towards. I can orient myself towards either say your domain controller or an application database or some sensitive files you have on some C-level executive's laptop, or maybe the IT admin's password list. My goals could be all over the place. Depending on what my goal is, I orient myself towards one of the available targets. Once I've oriented myself towards a target, I have a multitude of approaches available. Let's say I decide to go after your domain controller. If I'm choosing to go after a domain controller, do I just go there directly from the machine I have? Do I, pop up something that forces an admin to come and dismiss an alert once the admin has put their typed in their password to validate something with Windows? Their passwords are now in memory, and then I can dump it from there. Or do I try to actually pivot across the network to the IT segment, find an admin there, and compromise their machine? Or do I just go for gold and try something like cover roasting? Those are various approaches available to me. So I need to decide one of those approaches. And then finally, acting is where I execute my attack. Defenders, on the other hand, also have to go to the same loop, but we've kind of got a disadvantage here, where when the attacker's acting, when the attacker's in this final quadrant, that's when we start observing. We start observing that there's an attack happening in our environment. And once we've observed, we see where the attacker is, right? I'm getting logs from my domain controller. I'm getting logs from an IT admin's machine. I'm getting logs even from the machines of an HR, of some HR interns who probably clicked on some link that they weren't supposed to click on. So these are various places I can begin my defense. Where do I actually want to put my defensive controls in place first? These are the various options I have. Let's say I orient myself towards the initial machines, those HR interns that the command and control channel exists through. If I can do that, then I can essentially cut off the attacker's access across the rest of the network. I've oriented myself towards that goal. Now I've got various ways to exercise those controls. I can cut them off the network using network access controls. I can change firewall rules where they're allowed to talk within the same little subnet, but not across subnets. Or I could terminate user sessions. I could maybe change something on the proxy to disallow certain connections. After I've decided which of these approaches or which of these combinations of approaches I want to take, then I finally execute those. But obviously, as I said, if the attacker's starting their action, and that's when we're observing them, we're obviously way behind. And attackers are usually executing the attacks through scripts. So, that's not really something a human can compete with in terms of speed. So we got to do two things if we want to complete this loop first. One, we've got to speed ourselves up. If you're starting so late, we definitely need to go faster on all the steps we're taking. That's where that's where all your orchestration comes in. That's where you can use something like NIF's SOAR platform and have your various solutions take certain actions automatically. For example, if you've got certain types of attacks, let's say you've got known malware, something like WannaCry, for example, is something we see surprisingly even today in a lot of large enterprises. Now, while it is surprising given time that it's been about 2.5 years since the patch was released, when you look at the operational logistics, it's not really that surprising because it's actually a lot of ground to cover for any security team. Now, for that, we know how to respond to it. So we can essentially orchestrate something where when I get that alert, that tells me that, that patch is not applied, MS17010. It tells me that SMB version 1 is still enabled in my environment, which Microsoft recommends disabling. It also tells me that maybe my network segmentation isn't so great, right? I found certain weaknesses in my network segmentation. And I'd usually have a team member respond to that accordingly. Now, if I've got this knowledge ahead of time, that I know when I get this detection, this is what I'm going to do. Why is a human even involved in the picture? We could just automate this and spend the human's time and attention on something that actually warrants it. So that's where a lot of orchestration can help speed us up on the loop. And if we can slow down the attacker, then we can also gain a competitive advantage. The way we do it is through deception, where we create a bunch of decoy assets, which I'll show you in just a few moments how that works. The attacker's not quite sure which one they should engage with. If they engage with the wrong one, they go through and they attack the wrong network asset or asset on the endpoint. And once, let's say they even discover that it is a decoy asset, that means they still have to go back, orient themselves towards a different goal, and then decide on the approaches and then act again. So we slowed them down by essentially forcing them to reset a part of their loop. That allows us, with the combination of speeding up through orchestration, that allows us to really counter them much more effectively. So what is adversarial thinking? You can essentially think of it as a combination of a few approaches. One is red teaming. Now, anybody in the security industry worth their salt will tell you, it's not just enough to think as a defender. You have to occasionally actually test out your assumptions, see whether they work. Red teaming is one really effective way to do that. Another one, obviously kind of a little pet project of ours, is deception. You can combine the two of these along with the defensive approaches to go into threat hunting, where you start looking for threats proactively as opposed to just waiting in the SOC for the alerts to come to you. And finally, incident response, where we talk about how we really want to automate as much as we can, but there will be some things that require human attention, and how do we strategize a response to that? So just before we dive into deception, let's look at how we can make the attacker's life difficult with threat hunting, because red teaming and incident response is something pretty much anyone in the security industry today is familiar with. Even threat hunting, most folks are familiar with, but just let's take a quick walk through the concept. Now, back to the same old game from earlier. We've got you at the bottom, we've got the pot of gold at the top, we've got my SOC team and my defenses. Now, instead of my defenses being static as they were before, my threat hunting team could pretty much appear at any point on the entire enterprise infrastructure. So you can't be confident that if you found certain weaknesses, then that you can get past, because the threat hunting team could detect that activity at any point. So this makes your life a lot more difficult. And this, of course, works in conjunction with all your traditional controls like your IDSs, IPSs, and sandboxes, and so on. But let's step it up even further. Let's actually set up some deception for the attacker, where if the pot of gold is what you need to target, let's set up various pots of gold. As the attacker, this kind of leaves you in a sense of confusion, where what do you go after first? Imagine if each of these had some sort of motion sensor and light detectors on them that would notify the SOC team as soon as you touch them. So you have two options here. You risk touching the wrong one, or you don't play at all, right? You say that if I'm going to risk getting caught, you know what? I'm just going to play it smart. I'm not going to play the game at all. The game's stacked against me. Now, no self-respecting attacker is usually going to go for that, because there's a reason they broke in. There is a certain target they have that they want to achieve. So it kind of becomes a situation where if they don't attack, we as defenders win, because they haven't, even though they've broken in, they really haven't been able to cause any damage or any impact. That's a win for us. Or if they attack and they touch the wrong one, that gets them detected, which is much more likely than not. That again works out in our defense. Now, let's say I take away some of my traditional defenses, right? The problem for the attacker still remains the same. So this really helps to highlight the fact that deception can kind of augment independently the rest of the security infrastructure that exists. And consider that even the attacker still has the same problem, right? It's basic game theory 101, that you give them two choices, and either of which they pick are choices I like. Either they don't attack, in which case nothing's harmed, and if they do attack and they get caught, I'm still happy because I'm able to kick the attacker out of my network, particularly if I can orchestrate some of the more common attacks, defense against the most common attacks, sorry to say. And even if I do point out to you that one is the real one, notice that there's probably a couple of at least one other decoy you're going to hit on the way that you're going to stumble across and is going to look more valuable to you. Now, the reason we do this is there are a few underlying reasons. And one is that attacker tools and tactics change all the time. Anybody who's familiar with the show will know that each of these characters has different ways of getting what they want, getting to their goal. And the same thing goes for attackers. Just because a certain set of tools is known, has a known set of signatures, has a known set of command and control servers, and so on, does not mean that that is something we can reliably count on. There have been instances in the past where I think it was, I'm not sure which conference it was RSA, or one of the larger ones, I think in the second half of 2017, where where there was a vendor who famously put up banners that said, "We stop Mimikatz," which actually is a commendable achievement, because it's really, Mimikatz is notoriously difficult to stop. So rightfully they put it up for bragging rights. But less than 48 hours later, there was a patch out by Gentle Kiwi, the author of Mimikatz, that not just bypassed the detections, but also had an option to just, you can go look this up on Twitter, just to add insult to injury just for fun. We could also go and optionally stop that agent. And one of the competitors then says, like, look, we stopped this new patch version of Mimikatz, we stopped the old one without any changes. So obviously, we're better than our competitors. Well, what do you know? Another few days later, and there's another patch version of Mimikatz out, which can't be detected by this competitor's tool either. So if we rely on detecting what the attacker has done, we are by definition one step behind. The attacker is a step ahead of us because we're waiting for the attacker to make the first move. If, on the other hand, we can detect something that is the outcome of the attack, irrespective of how you do it, that outcome is something you as an attacker rely on. If we can detect that, then that really makes for much more capable defense. For example, if you want to steal data from a machine, no matter how you do it, whether you're an amateur who just directly connects to the machine, or whether you're a really skilled attacker who hops through 7 proxies and so on, you must connect to the machine at the end of the day if you want to steal data from a machine. Similarly, short of actually unplugging a hard disk from a machine, if you want to access files on the file system, you must touch that file somehow if you want data from that file. Whether you do that by clicking in Explorer or whether you do that by exfiltrating it and opening it offline in a sandboxed environment, it kind of really doesn't matter because you must touch the file. If you can detect the fact that you've touched the file, it kind of doesn't matter what tools you use. We can detect that outcome. We're not using what happened, not detecting how something was done to detect what happened. If we can detect what happened, then we can work our way back to how it was done. Another concept worth keeping in mind is the pyramid of pain. The further up this pyramid you go, the more trouble you cause the attacker. And that is something that we really want to achieve with. There's this famous children's joke where, there's two folks camping in the woods and a bear attacks, and the two of them start running. One of them says to the other that, we better outrun this bear or we're done for. And the second friend turns around and says, probably not a great friend, but turns around and says that, well, I don't have to outrun the bear. I just have to outrun you. That also applies to enterprise security, where if you're enough of a pain to attack, to an attacker, it starts becoming worth their while. If there is somebody who is comparable to you, who has weaker security, who's easier to attack, then you kind of don't become worth attacking anymore. It's standard, cost-benefit analysis for the attacker too. So how do we cause the attacker pain? Well, you'll see that on this pyramid, most of your IOCs fall in the bottom 4. And especially the bottom 3 are really no challenge to bypass. For hash values, even if I've got a multi-petabyte file and you've got a hash value for it, I change 1 byte and suddenly hash values are useless because a single byte is going to change the hash value of that file. So hash values are only effective against really basic attackers, really novice attackers. They will help you pick up commodity malware and commodity attacks, but they're not really useful against more skilled attackers. Similar thing with IP addresses, like with a little effort, there's probably 3-4 ways people can change the IP addresses on their phones within a minute, let alone on a machine that's dedicated for attacks, might even have a botnet with command and control behind it. So an IP address also becomes not a really particularly effective detection mechanism against an attacker. And domain names, while a little more difficult, they are still not too difficult, because you can have something called a domain generation algorithm, which most malware these days does have. And it can generate, depending on however the attacker prefers to set it up, you can generate thousands of domain names a day, and the malware will try to connect to all of them. But the attacker behind the scenes just needs to register one domain at the right time and have the malware connect and get orders. Whereas we on the defensive side need to monitor all of the possible domains for any possible connection. So the deck is again kind of stacked against us. When we actually start causing the attacker some trouble is the network and host artifacts, right? You can think of this as essentially analogous to the footprints you leave behind in the course of your attack. Now, if you're in the physical world, if you're kind of walking through, maybe performing some sort of attack, if you need to also wipe your footprints behind you in the course of that attack, sure, it's doable, but it's going to slow you down. It's going to make your life annoying and difficult a little bit. This is where you usually find the most effective IOCs, something like certain kinds of network traffic that an attack uses, or certain kinds of registry keys that are modified and so on. Those would usually fall in this bucket. Moving up to tools, this is where you finally really start causing the attacker some difficulty, not just in terms of slowing them down, where you're actually making them actively put in a lot more effort to have a successful attack. So an analogy to this would be, anybody in the defensive side has used Excel, analyzed CSVs and Excel files quite a bit. Now, imagine tomorrow if you were told that, what, our Office licenses run out, we're not renewing it. You've got to work with OpenOffice or LibreOffice. I'm sure you could still achieve what you need to achieve. But most folks who are used to working with Excel, they'll be slowed down. It would take them a lot more effort and time to achieve the same results that they used to in a certain amount of time with Excel. Something that used to probably take you an hour is probably going to take you most of a day in a tool you're not familiar with. If you can identify the tools an attacker's using, even if they kind of take the trouble to wipe the logs behind them and so on, if you can detect instances of certain tools being used, then you can essentially force the attacker to go on to their version of LibreOffice or OpenOffice. Now, what you're doing here is you're not stopping an attacker dead in their tracks. Just like you could achieve your goal with, alternative software, so could an attacker. But attackers have certain tools they're much more familiar with. Certain tools they know the right command line arguments to pass on, the right flags to use, the right parameters to run it within the constraints of. So sure, they could fall back to another tool, but it's going to be a tool they're less competent with as compared to their preferred tool. So you actually start making things challenging for them. Now, everything we've spoken about so far has been technical identifiers, right? It's either hash values or IP addresses or even the tools that the attacker uses. And on the other hand, right at the top of the pyramid are TTPs, tactics, techniques, and procedures. If we can start identifying these, we identify some human aspects of the attacker's engagement. And then it doesn't matter if the attacker changes all of the technical attributes in the lower parts of the pyramid, we can still detect that it's the same attacker. For example, if you have, let's say, you've detected an attacker that generally goes after, like in the example I was saying earlier, compromises a bunch of non-technical folks because, maybe they think it's easier to compromise them. From there, they pivot to the IT segment. From there, they elevate privileges to be one of the admins. From there, they then pivot to whatever server or domain controller they want to target. Now, tomorrow, even if an attacker is quite skilled and doesn't use anything with known hash values, doesn't connect to known IP addresses or domain names, doesn't have any of the same artifacts they're leaving behind, and is using entirely different tools. If you are observing your logs and once you've got a lot of the commodity stuff automated and out of the way, when you have the human team members actually analyzing the attack that's happening, and they see like, hang on a second, I see this attack having started in the HR segment, it's now gone onto the IT segment, and I see some privilege being escalated. Now, at that point, already that I have spotted this kind of behavior in the past, and I know what they were going after. So even though none of the technical parameters match what I have seen previously, the behavioral parameters do match. And this becomes a lot more difficult because there are aspects of human behavior that we don't spot ourselves, aspects of our own behavior. So it becomes a lot more difficult, a lot less likely even that an attacker will be able to spot it and change that. That's essentially what we want to cause. That's what we want to detect to cause the attacker a lot more pain. Because once we identify this, we can preemptively go and defend the resource that the attacker had previously gone after, the attacker with these CTPs. And even though we don't know how they're getting there, we can, for example, set up additional defenses in front of that, in front of the right server or domain controller, maybe step up our logging to monitor for any suspicious activity and so on. Basically, you want to give your attacker, your enemy a chance to make a mistake and not interrupt them, right? This image you see here is a famous one from World War II, where any World War II history buffs would probably know this. The Normandy landings were famously faked. They basically set up these inflatable tanks so that Hitler's aerial surveillance would think that the attack was happening at a different port in France called Calais. And even when Hitler's aerial surveillance did go over the place, they saw, what they thought were legitimate tanks, which were actually just inflatable tanks they'd set up. They actually had some actual soldiers there too, just to kind of add icing on the cake. Hitler set up his defenses for Calais, and the Allied powers were able to attack from Normandy. That's essentially what you want to do on your network too. You want to set it up so that the attacker is constantly wasting their time on things that they shouldn't really be spending their time on if they were to successfully accomplish their goal to achieve what they're looking for. But you're stacking the deck enough against them that they don't really have a choice, far as they know they are actually engaging with a legitimate target. So just to kind of pull it all together, uh, if you want to apply adversarial thinking, uh, we need to kind of start thinking in terms of graphs and not lists. Uh, we also need to ensure that we speak the language of the attacker. If you get a sense of how attackers communicate, how they achieve what they achieve, you're much more able to do a better job at defense. This goes back to that adversarial thinking equation earlier. I'll touch on that again in a minute. You need to break the attacker's OODA loop, complete yours before they do. That's as long as you can outpace them, whether that be by speeding yourself up or by slowing them down or through some combination of the two, you can cause them a fair bit of inconvenience, slow them down, and essentially outpace them, break the loop, and win. Like I was talking about, the equation to keep in mind simple enough, where if you can combine red teaming, where you'll have folks on who are assisting the defensive teams, but who are actually performing offensive exercises, combine that with deception and threat hunting and a capable incident response platform, you can essentially really make it much less worth the attacker's while, and make it so that the attacker maybe even thinks twice about attacking you. Maybe you're not even worth being their target anymore. Additionally, if you can set up a good threat hunting practice, you can significantly reduce dwell time. Attackers can usually linger in the environment. Now, obviously, every analyst has their own numbers for how long this dwell time is. Somebody it's 90 days, for somebody it's a year and a half. I think the last report I read has been a while. It's Mannion's report from last year said that in Asia Pacific it was about a year and a half. So I think some 490 days between an attacker breaking in and actually completing their attack. So if you can cut that down before they complete their attack, before they actually achieve their goal, you can stop them. Breaking in is, as much as we don't like it, it does not achieve for the attacker what they're seeking to achieve. So we can prevent them from getting to their goal. Um, Basic game theory, like I was talking about, set the attacker up so that they must take two choices, both of which you like. You can essentially break their OODA loop, and you can, if you can find out what happened and then work back to how it was done, as opposed to using detections that say only if I know this is bad, then I will flag it as malicious, where that was one of the reasons traditional signature based antivirus has kind of been a lot more phased out these days, because it would use how something is being done. How is this file different from others? Okay, it matches the signature, to figure out what happened. That means if I can't figure out how, I essentially say it's all right, it must be good, which isn't really an effective defense approach in these days. Whereas if you can figure out that something is happening, even if you don't quite understand how, when you know something's happening, you can kind of direct your effort to figuring out how it was done and not work the other way around. So in sum, that's the single greatest change you can make to your security, even without any tool. If you can start thinking about some of these concepts, start trying to apply this kind of strategy to your defenses. If you can start trying to think adversarially, you can actually make it a lot more capable a defense that you're exercising in your organization. I'll just before I dive into the demo, I'm going to take a couple of quick questions. Mohammed has asked in the Q&A, does deception learn the network info automatically, and how effective is deception detection in cloud infrastructure? Now, whether it learns it automatically actually varies from tool to tool. The way we do it, we do have something called Mirage Maker, which, the name is fairly straightforward. It makes something that is fake but looks real. It's going to study the environment and see, okay, I see a bunch of Dell servers around me, so maybe I should also pretend to be a Dell server, right? I see that there are a bunch of file shares and a bunch of web applications here, and one database. I should have a similar setup for my deception. And maybe just to have something that looks worth targeting, I'll have one machine that looks different. Maybe you have a bunch of Dell blades. I'm going to run an HP server instead, and I'm going to set it up with something like Linux SSH prompt. And for cloud infrastructure, you can deploy it similarly to the way you do on-prem infrastructure, where it's a little bit different in terms of technical prerequisites, but conceptually it's the same. It's a remote network, so we need to deploy the decoys remotely, but that can technically be done. We've got that running in quite a few organizations. Vaibhav had another question that says, how does one deal with deception
And with deception cache and fatigue that may creep in after a chain of pseudo attacks launched by the adversary, have you come across such a situation in the past? That's actually a fantastic question, because what if the adversary tries to set up deception against us, right? This is where a lot of the orchestration would help. If you've got a lot of your defensive approaches automated, then you can afford to spend time on some of these alerts. Even if the attacker is trying to psych you out, you can find out where that fake attack is coming from. Forget what they're attacking. Figure out where the attack is coming from. That machine is definitely compromised. Even if it's being used to run pseudo attacks, that machine is definitely something someone else has control of, and I don't want that. And that's where I will, from that OODA loop earlier, I will orient myself towards that machine and remediate right there. So then I don't care about whether your attack is a pseudo attack or a real one. I can just shut down any activity that you're doing whatsoever. And we haven't come across this so much in the wild, but like I was talking about earlier, our red and blue teams, we do a fair bit of research internally. We have tried this out. So that's why I was saying that it's actually not a very common question. Definitely a good question, Weber. And Vamsi's made a note of looking at the MITRE attack framework. That's actually something I'm going to touch on in the demo that I'm going to get to in a minute. How to pick up an area of the attack framework and to start threat hunting. All right, that actually gets me right into the demo quite well. Let me just pull up my dashboard. Right. So this is our platform. We've got okay. My network looks good. This is usually what you might see with a slight bit of activity. In a perfect world, because you have decoys, nobody ever interacts with any of the deceptive assets. In a perfect world, this is what it looks like. You've got nothing on the dashboard. Because if you're a database admin, for example, you know which databases you need to administer. You're not poking around at random databases on your infrastructure and saying, hey, can I administer this too? Right? You've got a sense of which machines you need to work with. Similarly, if I place some fake files on your machine, you're not enumerating your entire file system all the time, especially if I tell you that this file is a decoy. It's serving no legitimate function in your day-to-day work. So you have no real reason to interact with it. Whereas to an attacker, if I can make it look like, I've got a hidden passwords file, then, well, it's a passwords file, it's hidden, so it must be valuable. On the other hand, I could also have something like a confidential agreement, and you're never really going to use that agreement because it's a fake one with fake information in it. But to an attacker, that might as well be real, right? If you lie on your network, once we break in as attackers, we don't really have a sense of what's what right away. It takes us some time. So if you lie, we'll believe you, because as long as it looks like it's something that is told to the rest of the team too, we're going to believe it, because we're going to be like, look, you wouldn't lie to yourself, would you? So let's talk about a couple of ways we can actually carry out some of these attacks. We can set up some public-facing decoys, where just internal decoys, but we can set up unlisted subdomains. So let me just see if I can run a quick brute force. Let me just see. I think I've lost my window there. All right, there we go. Yep. Now, multi-monitor setups never quite work the way you want it, right? So I've set up essentially a fake company here called Actus Ventures. I've got my DNS recon tool saying, just go search for the domain, run this tool against the domain actusventures.com. The type of attack I want you to run is a brute force attack. And the dictionary I want you to use for this attack is this subdomains text file. Now, just to give you a sense of what's in that text file, let me just open that up. Just give me a second. Yeah, so this file is just a simple list of subdomains that might exist for any organization. So what this script is going to do is it's going to go look for www.actusventures.com, see if it exists. It's going to look for mail.actusventures.com, see if it exists. It's going to look for FTP, and you get the idea. So that's basically what I'm going to tell the script to do at this point. And parallelly, I'm not really running it right now because that could take a little while. You could have a crawler that goes and crawls the entire website and says, just find every subdomain that's linked to on the website. Now, let's say I find 10 subdomains on your website that have been linked to from your various pages, and I find 11 or 12 of them on my DNS recon. That delta of one or two tells me that you've gone through the trouble of making sure these subdomains exist. They exist in your DNS, but you're not linking to them anywhere. That means anybody who needs to access them already knows where they are, right? They're not going to get through it by clicking, but they might be, employees or contractors who know that they're supposed to type that email .arctusventures.com to get to their mail server, or they're supposed to type vpn.arctusventures.com to get to their VPN server, and so on. Whereas I don't really need to link the rest of the world to that. So we see a couple of results beginning to come through now. Let's just see if we can access vpn.arctusventures.com. And sure enough, I've got a VPN login page. Let me just maximize this a bit so that folks at home can see what's going on. I'm essentially going to log in as admin. Now, in this case, you can even have your own virtual keyboard set up, so you can type in whatever password you have that matches your policy or something of that sort. Now, this can be as in-depth or as basic as we'd like. Even if nobody logs in, even if they just load the page, that tells me that the attacker has gone, probably brute force my DNS. Now, regular users at home visiting a website don't have any reason to brute force your DNS, right? So that automatically becomes suspicious. This automatically raises a flag that why is this person doing what they're doing? And I can attempt to log in. My login fails. I can have this go into a few steps of depth if I would like. I haven't really bothered setting that up in this demo, but you could really have it go as detailed as you'd like. And you can see that our activity has been detected. And again, in a perfect world, nobody interacts with any decoy ever. Let me just zoom in so that folks at home can get a clear view of that. Now, as you can see, I'm coming from an MTNL connection. Now, if we click on this attacker and see what activity was done, this is where we get something we like to call thread parse. I'll just reload my page after turning this up a bit, so the folks at home can actually get a better visual of what's going on. I'm just going to give this another few seconds to load. Sure enough, right? The demo gods don't like me. When something's supposed to work, that's the one time it won't. All right, there we go. We have our dashboard loaded. So now when I click on this attacker and I want to see what they're up to, or I want to see what happened on my threat intelligence decoys, thread parse tells me the same way I communicate with the rest of my team, right? When you're talking to your team, you're not usually saying stuff like TCP port 80 send synac HTTP 1.1 get index.html. You're not saying stuff like this. But usually those are the logs you're dealing with, right? So thread parse is basically going to tell you in plain English, hey, that was an attempted login. Now, if you want the technical details, you can go through. You can actually correlate this quite well with the rest of your infrastructure through your SIM or through a SOAR platform. But it's going to give you a quick introduction of what happened. And you can see the credentials that have been dumped in. Now, all of this is going to your SIM. And what you can do is then you can see whether the same user also from the same IP, were there any access attempts to my legitimate infrastructure? Was this user actually logged in at around this time on any of my legitimate actual infrastructure? Is this password valid? Then I probably want to reset the credentials. This is some of the stuff we can automate, that if somebody ever logs into a decoy on the public facing decoys with a valid password, automatically reset the user's sessions, change their password, just reset their password, force them to set a new one, and enable two-factor authentication if available. Also send an email to the SOC, send an email to the user, and check for any active sessions on legitimate infrastructure and terminate those. And you can tell your firewall parallelly to block this source. So you can really piece that together quite well. Another thing we could do is, I'm just going to pop over. Let's say this is a compromised machine that I have managed to get control of within Arctus Ventures. I'm going to try something simple enough where I'm just going to look for interesting files on this machine. Let me just turn up the font once again. Well, there we go. So I'm just going to run a basic script that's going to say find interesting files to the folks at home who are familiar with Power View. That's basically what I'm using here. I'm going to tell it to find interesting files on this machine. Sure enough, it finds important docs on the desktop, the important docs folder. Now, even though that folder is hidden from the user, my tool kind of doesn't really care what the user's seeing, right? It's querying the file system directly. So I could just change my directory to important docs. As an attacker, let's say I want to exfiltrate this passwords file. And I could just say, I mean, right now I'm going to copy it locally, but I could copy it to, right now I'm going to copy locally to passwords_1.xlsx, but this could just as well be a remote server that I have. I'm exfiltrating data to, I suspect that you have deception deployed. So I'm going to, play it safe. I'm going to open this file offline. And even just for safe measure, I'm going to open it in a sandbox just in case. I'm going to monitor what activity it has. And sure enough, I've got the passwords file exfiltrated. In fact, if I just quickly open up Explorer and show my hidden files, on my desktop, I'm going to see that important docs file. I'm going to see that the exfiltration was successful. On the other hand, even though there was there's nothing to indicate to the attacker that their activity was detected, we can detect it. And all of this doesn't require an agent because, I mean, I'm guessing a fair number of you have already heard that, heard of what's called LOL, right? Living off the land. That's something attackers like to do, misuse built-in Windows components to perform attacks, because an attacker is basically a sysadmin with malicious intent, right? If attackers can live off the land, why can't we? So that's basically what we do. We use built-in Windows utilities to tell us, hey, if anyone accesses this file, tell Smokescreen. And then Smokescreen, of course, forwards it to DNIF and other controls you have in your environment as you set it up. And if we say what file theft activity has occurred, we can see that file decoy interaction was attempted. And we can also see that, somebody attempted to access my passwords file with PowerShell.exe. Now, I don't know about how your environment is run, but my environment, generally, Office files are opened with Office, not with PowerShell. So this becomes a very high fidelity alert to tell me that something's going wrong. And also because attackers generally have a goal of causing some sort of data theft or manipulation. If they're interacting with my decoy files, they're probably also rifling through my real files. And that tells me that the attacker is probably close to completing at least some portion of their attack. This is an alert we get so rarely that, we actually have some clients who have set up automated orchestrated actions that say, if file theft is detected, just automatically tell my NAC through my SOAR platform to quarantine that machine. And if a network admin, for example, accidentally opened that file, they knock themselves off the network as a result, they'll contact me and I'll get them back on the network within a few minutes. I would much rather take that risk than taking the risk of someone exfiltrating data and me not acting on it just because my team was swamped with something else. Like with the target breach, they had good tech, they had FireEye that detected a lot of those alerts. I forget, it was somewhere between 5 and 10 alerts of their malware.binary field. But because those alerts were not acted on, the attack was able to be completed successfully. Whereas we can prevent something like that from happening just through pure orchestration, where even if this happens at midnight on Sunday, we don't really mind because we've got our response orchestrated. And just as a final part of the demo, let's say, I'm going to be smart about it. I could run a network scan, but that'll be noisy. I want to be stealthy, so I'm not going to do that. What I'm going to do is I'm only going to interact with the assets that this user, as you can see here, the user Eric here interacts with. Let's just turn up the font on this one too. Yep. I'm going to look at the resources that Eric interacts with and only interact with those resources so that even though I suspect you have deception, I don't hit any of your deception, right? So I've got a tool on my desktop called Lasagna. I'm going to tell it, so I can tell it to dump my saved browser passwords. I can tell it to dump credential manager passwords. I'm just going to tell it to dump everything it can find. And sure enough, it finds a bunch of saved entries. It finds passwords in my vault. It finds my credential manager passwords. It's found passwords in Chrome. So think about this. When's the last time you might have seen your browser pop up and say, hey, do you want to save this password? For those of you that use password managers, same thing, right? You might have accidentally clicked save when you typed in the wrong password, then you go and correct it. Everyone's been through that once or twice. But when's the last time you purposely saved the wrong password in your password manager? Nobody ever does that. So what that to an attacker says that if I can find your password manager, I can trust it like gospel. Anything I find in your password manager, nobody lies in their own password manager. So anything I find in there, I can believe. So I can actually believe that Eric uses this password on the SAP server. He uses this password on his SAP backup server and so on. So let's actually try to access something that Eric works with day to day. This tells me that either this is something Eric accesses frequently, that's why he just wants to save the password to avoid the hassle of having to log in again and again, or it's something he accesses infrequently, but can't afford to forget the password of because it's so valuable. I still want to know what that is. Uh, you can set up your own certificates. You can actually feed in your own certificates onto the decoy web servers as well. So I'm going to log in as Eric using the password I found. Now, once I log into this password, once again, in this case, I've just set up a basic demo where it just refreshes the login page, but you could actually have it say, wrong password, please contact admin or something of that sort. And sure enough, I see that activity coming through in real time on the dashboard, right? So we essentially cut our detection time down from, hours, weeks, months, depending on the various stats you believe, to seconds. And we can see that there was an attempted web login. And if I check what credentials were used to log in, I see that this is the password. Now, this password, Smokescreen left behind purposely as a fake password in the password manager for the attacker to find. So tomorrow, even if this password comes from one of the other machines, I've got another user called Felix set up in my environment. So if even if that is accessed from Felix's machine, the fact that Eric's username and this password was used tells me that the attacker was on Eric's machine and has accessed the Chrome SQLite DB that stores the passwords at some point. So I can go through my logs and look for those specific selectors, and instead of having 1,000 log lines to look through, I can look through just maybe a few tens, and that really cuts down my time to analyze. Even in the cases when I can't automate it, when I really need to do manual analysis for something like this that deserves manual attention, I can cut down the amount of time it takes me to analyze. And all of this, of course, is being sent to the rest of your orchestration platforms. And you can even set up rules where you can say when something is when a certain type of activity occurs, you can set whatever rules you would like here. So you can say, if my decoy dot name is admin db, or whatever. You can really, I'm just making stuff up at this point, but you can get as complex or as simple as you'd like. So you can say, if the type is let's say I'm only looking for web access, then when you get this type of activity, I want you to notify certain people and forward it to Net Monastery's NIF platform. And maybe also if you've got NIF's SOAR platform, then you can just set it up through there, or else you can set it up through here saying that send this to Cisco ICE, for example, or CrowdStrike, and set up policies on that end for what action you want to take when a Smokescreen alert comes through. So you can get fairly detailed with this. But I think that's it for the time I have. Just to touch on your point, Vamsi, I'm sorry I missed that point earlier. We're also mapping a lot of this activity we are seeing to the appropriate MITRE attack ID, so that, well, one, this helps analysts kind of upskill and learn various attack types, and it helps security team managers get a sense for where in the matrix they're covered and where their blind spots are. Just to check out if there are any other questions left. WebHub is also curious about the utility of pseudo attacks, especially carried out for disorienting security efforts and being able to really meaningfully fingerprint the adversary. The end goal of typical diamond model. Actually, WebHub, that's another good question. I would say that you can, because we're agnostic to what the attacker is doing, we can fingerprint. We don't want to fingerprint just their technical parameters, like what tools they're using or what hash values I can use to detect their tools. Like that pyramid you might remember from earlier. If we can identify the human aspects, if we can use a technical fingerprinting as a mechanism to understand the human fingerprinting of things, then we can figure out aspects of the attacker's methodology that stay true irrespective of the kind of tools or environment they're in, the kind of things they prefer to do. And I think that's it for questions. If any come up, please feel free to feel free to drop them in Q&A. I'll answer the ones I can. I can also answer them later if we connect offline. I can be reached at the email address in the slide from earlier. I'm just going to share it once again for those that need it. All right, thanks. That's it from me. Over to you, Mervin. Cheers.
Thank you very much, Kush, for that presentation. It was really, really great. Uh, Once again, there's a lot that we got to learn in terms of how technology is used, and that was really nice. I mean, during the rehearsal, I had a feeling, that they were holding out on on many things, and then I realize now why. There's a lot of information in that. So it was. Thank you very much for that. It was very great. I'm really happy that you took this opportunity and you came here and imparted your information. Okay, so with that being said, once again, we have would like to thank Smokescreen for being our technology and knowledge partner, contributing that knowledge that that Kush just provided to us, right? And thank you very much for that. Yeah, the whole idea about this community is very one simple thing, is to come here, connect, build together, and understand, learn, and contribute, right? The whole idea of this is that. So the idea is then contribute by giving us your information and writing, going on to slack.nif.it, asking questions in case we missed out on any questions, or you remember questions on a later date, right? You can always go to slack.nif.it and you can go there, write your out. If you feel like you can answer questions as well, interact into the community members, you get to learn a lot over there. Also, you can mail us at connect@nif.it. One of the this slide I put in there for a very specific purpose, right? So I understand that there's a lot that we're doing, right? I mentioned as we started, like there's a lot of people doing a lot of work. They sit in front of their desk, like they keep staring into their systems, and they look at logs, they look at data, they try to figure out attacks, try to figure out possible threats. There's a lot of things people do, right? So I want to take some time out. Don't be a desk potato, right? Eat right, work out, stay active, stay healthy. That's the major thing. If health is wealth. I tell this to my teammates, and half of them are giggling and laughing at me right now, right? But the major idea is that, right? So if you have your health, you'll be able to find out new ways of detecting threats. You find out new ways of figuring out different things. I tell this every day. So a healthy mindset, right? A healthy body is a healthy mindset. That's the most important thing, and I'm taking a little time on this. It's very important. I believe this. I believe this is the thing that I live by. So yeah, so don't be a desk potato. That's all I want to say. Yeah, community captain award, one of the major things also. So as I mentioned earlier, you can keep asking questions on stack.nif.it, and you get a chance of winning 1,000 rupee gift voucher from Amazon. So just keep interacting over there, keep contributing, and keep learning. And that's as simple as that. I'll again that anyone is free, anyone from the community is free to share their knowledge and become a Connect community hero, just like Kush. And so he's joined the list of Connect community heroes that have passed. So all you need to do is write to us at connect@nif.it. Write in your write in your topic, what you'd like to talk about, and tell us a little bit more. We'll definitely contact you and figure out how do you fit into this into the whole imparting knowledge aspect that we're touching upon, right? Once again, yeah, so we're thanking Smokescreen once again because Mukesh, for some reason, for connectivity issues, will not be able to connect this session, right? So what we're going to do is we're going to reschedule her for the next Connect that is coming in the next month, right? Oh, she's going to talk about NIF command and control, which is going to be a part two of a two-part like a session, wherein in part one she covered a lot of the aspects of how do you debug a lot of the issues with with NIF, and how do you troubleshoot and solve problems with NIF using DCC, how it makes easy for our partners and customers to use it, right? So part 2 is going to be covered by her in the next session. That will be the next Connect. So yeah, I'd like to now take the opportunity to announce the winner of the best question asked. So I will go on mute and have a discussion internally with my team, which is going to take about a minute or maybe under that, right? And we are going to announce the winner of the best question asked for this particular Connect, that is Connect number 7. Okay, so just a minute. Okay, so after evaluating some of the questions, the team has gone in the back end and evaluated some of the questions, and the winner of the best question for this particular Connect, that is Connect number 7, is Saurabh Patak. So, Saurabh, thank you very much. Congratulations on winning the Amazon voucher. You shall receive all related information on your emails very soon, right? Within the next 1 to 2 days. Rest assured, you will receive the Amazon gift voucher in the next 1 to 2 days. Congratulations once again, right? With that, I would like to end this particular NIF Connect, right? The major aspect of ending a NIF Connect is to thanking all the people that were part of this Connect and thanking them for their contribution and all that they have done to make this possible. So big round of thanks to our guest speaker Kushaagra Mehra for his presentation and contribution, right, and the time that he spent in contributing towards NIF Connect. Would like to thank Bharat for his insightful presentation on NIF and Smokescreen, and how both of them can work together to solve a lot of issues. Additionally, also would like to thank Lenora and Ravi for working in the background to make things possible. I know they've presented at multiple occasions, but they also do a lot of work in the background to help things smoothly go through, right? So thanks to you all guys. Would also like special thanks to knowledge and technology partners Smokescreen. Again, this is the third time, but it doesn't go without saying, right? It's very highly appreciated. Thank them very much. Last but not least, would like to thank all attendees, right? That is the major aspect. The attendees are the heroes over here, because they attend, they make, they are part of the community. They are the ones who contribute towards the community and make it grow and exponentially, in ways that initially when we came out with NIF Connect were not able to see it grow to this extent, right? So thank you very much, and thank you. Keep contributing. You can expect to see us, no, sorry, expect to hear from us on the next Connect, that is in the next month. We're already planning for that. It's going to be great. So thank you very much. This is Mervin signing off till next session. Stay fit, stay healthy, have fun. Good evening.